In this video, we will look at a couple of 3D printing projects. A door stabilization project where we recreate the functionality of the original. The model was redesigned with no round corners and some changes to better fit with smaller screw heads. This is how the final model looks in Blender. The second project is a wheel cap clip project, where we replicate the functionality of these wheel cap clips. Here you can see the new clips together with the original ones and a close-up of one of them. There were quite a few versions made of this clip. Version 1 was close to the original one, but because metal had more resistance than plastic, it needed to be adjusted for it to have the same functionality. Version 14 is the final version. Here you can see the model in Blender. When we want to recreate a model, we first need to measure the model and write down the main measurements of it. Inside Blender, we need to select the units. In this case, we use millimeters. Then we drag an image into the view for reference. Set it to 0 in the X, Y, and Z axes and adjust the model to fit the scale that we have written down. Here we have 89 millimeters on the height. And then we scale down the image to fit the model, so we have the image at the same scale. On the model, we set 4 millimeters on thickness, or y-axis, and width to 20 millimeters on the x-axis. Here we scale the top to get it to 16 millimeters. We are going to be using Booleans to cut holes in the model and create the parts we need. Create a cutter object box 9 millimeters large in all axes. Sizing one object and copying it to the second opening. Here we are adjusting the placement both on the depth and the placement from the front. We join the two new boxes to make it one cutter object. The Boolean itself is done by selecting the model, adding a Boolean modifier, and then selecting the cutter object. When we hit apply, the Boolean is final on the model. We then reuse the cutter object and resize it to create the inner cut, which is 3.5 millimeters. Making sure it's all the way through to the other end so the cut goes through. After some more adjustments, this is the final model, as you can see here. Here, we will export the model out to the 3D printing software using the STL format. Note that internal Blender scale is different than the scaling factor in the 3D printing software. So if you select 1 as scale, the model will be very small and you have to scale it up manually. Using standard resolution for printing. Larger resolutions will take longer but look smoother. You can also try to lower the resolution when test printing to save time and material. You can see that the model will take 24 minutes to print. To get the model the right size initially for the export, we can set the scale to 1000. Printing the model at standard resolution. This is how it looks when finished printing. Here you can see the final model on the door, together with the original model. The second example we will look at is wheel cap clips that make sure the wheel cap is fastened to the wheel. This is 2 of the clips replaced. The other clips here are the original metal clips. Here's a close-up of one of them. These images were used as reference. You can see that the originals are quite rusted. Several different versions were created. Version 1 was close to the original, but had several issues. The first issue is that metal and plastic are quite different materials. Both the top and the bottom did not fasten properly. The issues were improved through several revisions and test prints to find something that worked. You can see that both the top and bottom is formed to clamp better with each version. Version 14 is the one I ended up using. To model this, we start off with a plane. Extrude it so it fits the curve as shown here using Ctrl plus right click. At the end here, we merge points to close the geometry and adjust the points as needed. And then we extrude the model. Here you have to make sure it has the same depth as the original. We add a subdivision modifier to make it smoother and add edges to reduce the amount of curve some of the edges make. Then extrude the bottom fastening mechanism. After a few different versions, this is the final model. Another way to model this is to merge the points in the plane in the beginning so there is only one vertex before we extrude the model. Then we can use the solidify modifier to dynamically create the thickness of the model.